also must have heard, I hope, something called GNSS. Have you?
Yes, sir.
GNSS?
Yes.
Okay. So Mohit, now that you have responded, you are caught. Tell us a little bit about GNSS. What is GNSS that you understand about it? I'm trying to basically tell you. It
Yes,
is
sir. It's basically the system of satellites which are used for navigation purpose and plotting of positions and all.
good. In general, very good. GNSS is Global Navigation Satellite System. This is a generic term for any system that uses position fixing, that uses satellites for position fixing on the surface of the earth or near the surface of earth. Any system using satellites to fix position on the surface of the earth or near the earth is GNSS. GPS, as we know, is it using satellites? Is it fixing position? Is it giving position on the surface of the earth? Is it giving near the surface of the earth? Position fixing near the surface of the earth? Is it giving? I think yes to all. That means GPS is a GNSS. Going by the same logic, there are other systems like GLONASS. Russia has got a system of position fixing which uses satellites, and that also gives position on the surface of the earth or near the surface of the earth. So GLONASS is also GNSS. Similarly, China also has one, something called BeiDou. I don't know if I'm pronouncing it right.
Baidu, sir. Yes, sir. BEIDO.
BEIDEOU.
Yes, sir.
So
Baidu.
yes, whatever it is, they call it, or that means what we are trying to say is that China also has a system of global position fixing system. India also has started, but it is not global as such for now. What we have is regional. So we get our position using our satellites in the Indian Ocean region or Indian coastal region. European Union has their own, something called Galileo. So all these are basically GNSS. This is the generic name. Any system which is using satellites to fix position is GNSS. For marine navigation, as of now, GPS system is approved system, recognized system by the IMO. And if you have a position fixing system which is GPS, it is allowed. But not only GPS, IMO also recognizes GLONASS. So either you have to have a position fixing system or receiver on board ship, which is working with GLONASS or working with GPS. Both are, so to say, okay, but terms conditions apply. So what is that terms and conditions? It is that separately GLONASS is not allowed. In today's world, the ship which is having a position fixing system, GNSS receiver, it should be able to work with GPS satellites and GLONASS satellites both. There are certain satellites which are GPS satellites. There are certain satellites which are GLONASS satellites. GLONASS satellites are handled and operated by Russia, GPS satellites by USA. We as civilians, especially in the merchant navy or navy scenario, we have to have a receiver which is able to receive signals from both of these, process and give us the position. What is the benefit? The benefit we can understand from a simple example that I'm standing near the shore area somewhere anchored. I want to fix my position taking range and bearing. Should I take one object for range and bearing? That will be good. Or if I take 5 range and bearings, that will be more accurate position fixing for me.
Sir, more the object, more accurate.
More the observations, more accurate it is going to be. So naturally, if we had 4 satellites of GPS and there is also 3 satellites available of the GLONASS, now we have 7 satellites जिससे मैं position fix ले रहा हूँ. Naturally, there will be improvement in the position. The fix will be more accurate. So that adds to it. Since more number of satellites are now available for me, I am little less dependent. I have more choices. I can always choose more number of satellites. I can choose means not manually. GPS receiver automatically all by itself chooses from available satellites. So the GPS receiver has got more choices of satellites, so the position is better. Conversely, on the other side, the Galileo, which is European Union system, it is also going to get recognized by IMO. Almost they are in operation. I'm not sure whether it has been recognized as of today or not. But IMO performance standards for position fixing devices or GNSS receiver on board so far has not included Galileo. Maybe work is going on. Discussions are going on. Just this general discussion only. Galileo is a system which is more accurate than GLONASS and GPS, so to say. The kind of accuracy that the GPS gives, Galileo gives much better. So much so, it is reported that the position fixed by Galileo system is within a range of 1 meter. मैं यहाँ पे हूँ, इधर 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 1 मीटर के भीतर में होऊंगा. So accurate. So you must have heard something called DGPS, differential GPS, जो पढ़ेंगे भी हम, उसकी भी जरूरत लगता है खत्म होती है उससे. Additionally, Galileo is having more features, safety related features. Like what? So if they like EPUB signals they receive, one feature is that they receive the EPUB signals. If the EPUB signal is received early, as of now, we don't have any indication whether it is transmitted, received or not. We don't know. We hope it was working, it has been received. Generally, it is happening also. But Galileo also includes a feature where once it is received by the satellite and it is delivered to the shore authorities, we get a notification back. Your message is delivered. Delivery confirmation kind of thing. That will put us in more ease that, okay, my message has been received by the shore authorities and they will be doing something now. So certain features have been enhanced. So multiple systems available. it is allowing us to be more independent. In our syllabus, we have got GPS still, but we also need to know a little bit about GLONASS, maybe Galileo. तो आपके नोट्स में मैंने थोड़ा सा कुछ उसके बारे में लिख के दिया है, so that you can familiarize yourself. The point of understanding should be that all the systems have got similar situations. The principles are same. The facts may differ from system to system. किसी में 24 सैटेलाइट है तो किसी में 18 सैटेलाइट होंगे, किसी में एक ऑर्बिट में 4 सैटेलाइट है तो किसी में 3 होगा, किसी में प्रोसेस ऑफ ऑपरेशन कुछ होगा, लेकिन अल्टीमेटली method of position fixing remains same. The system as a overall system remains the same. There will be satellites in all the system. There will be ground-based stations to monitor them. All the systems will have that. Users like you and I, all the systems will have. I can use this, I can use that, I can use that. I should be having a receiver to work with any one of them. What is referred to as the segments of GNSS? Space segment, all the satellites. Ground segment or control segment, to control all the satellites, to give them data to transmit, to put them in orbit. If something has gone bad, उसको हटा करके दूसरे satellite को active करना. So there has to be a control system or ground control system to monitor and manage all the satellites. And then finally we are here where we have a receiver, a dabba, which is having a computer, which is having a screen, few buttons, an antenna, and I can see my position. The user segment. These are 3 segments: space segment, the control segment or ground segment, and third, you and I, the user segment. All the GNSS will have this. So we will focus more on the GPS because it was the first and foremost, and it is still in the syllabus. The GPS, what we call the global positioning system, is basically having a full name of something called Navstar GPS, Navstar. Navstar GPS. Navstar is basically NAV for navigation, S for satellite, TAR is for timing and ranging. Navigation, satellite, timing and ranging global positioning system, GPS. In the name Navstar GPS lies the crux of method of position fixing. The GPS system, how it fixes position, what is the core activity in position fixing is in the name itself, called timing and ranging. So you should keep this word very close to you, timing and ranging, because this is an important function that is performed by the GPS receiver, timing and ranging. Now, what is this timing and ranging? How is the position fixed? We'll take a look at that. We'll go to the slide. I have made some animations, so it will be easier to understand from there. I can do it on the board also, but same thing is there on the slide also. So we'll do that on the slide, but now that we are talking, the GPS system actually started way back in 70s. It was a military operation, and it remained military operation for 20 years or so. it was used only for defense purposes or offense purposes. But come 90s, it was open for general public as well, for civilians as well. The advent of GPS was a flash of imagination from a situation. एक idea आया एक situation. You know, way back in 70s, there was Cold War happening between USSR, the then USSR and USA. So they were spying on each other. Everybody, both of them wanted to know वो क्या कर रहा है. And there were lot many satellites going up in the sky. They wanted to monitor किसका satellite कहाँ है. So they had set up few observatories on the earth, different places, and they would try to receive the signal from these satellites. Because satellite हर कुछ transmit नहीं करे तो फायदा नहीं. जो देख रहा है वो बताएगा भी तो कि मैं मुझको ये दिख रहा है कैमरा में, तो ट्रांसमिट तो कुछ करेगा. तो मॉनिटरिंग वगैरह कुछ चलती थी. So they were having some stations on the ground and they could find out, probably, as the story goes, they could locate कि उनका सैटेलाइट वहां पे, रशिया का सैटेलाइट वहां. One smart gentleman reversed the process. He said कि अगर हम स्टेशन से रख के यहाँ पे अर्थ पे और सैटेलाइट का पोजीशन पता करते हैं, तो सैटेलाइट से हम अर्थ का पोजीशन क्यों नहीं पता कर सकते. This was the whole idea. And they worked on this. In 70s, they developed a system by which the position can be fixed on the earth also. Of course, there were glitches and improvements तो हमेशा होती रहती हैं, तो वो हुआ. Meanwhile, Russia did not want to find itself behind from the USSR, so they started their own affairs, their own exercises, and they also launched this kind of system. Others follow suit. So the idea is that how these satellites are helping me find my own position. One thing that I know, that I have a receiver. एक डब्बा है मेरे पास जहाज में या पॉकेट में, मोबाइल में, और उसमें मुझको लैटिट्यूड लॉन्गिट्यूड दिख जाता है. कैसे दिखता है? What is the theory or what is the process of finding position? Basically, the GPS system or the receiver does few mathematical calculations. Mathematical calculations के लिए कुछ inputs होना चाहिए, and then there will be some output. Simple. So for calculating position, the GPS receiver will require two inputs. दो चीजें चाहिए. क्या? So one, the location of the transmitting station, वो कहाँ पे? And the second is how far it is from me. Range कितना है? Maybe station is there and I am some 500 kilometers from there. So exact location of the transmitting station and the range from there. If we have two of these information, I can do some mathematical calculations and try to find out my own unknown coordinates. उसका latitude longitude मालूम है, उससे range मालूम है, तो मैं अपना range निकाल सकता हूँ, अपना range नहीं, अपना position lat long निकाल सकता हूँ. So we will take a look at this process by means of an animation which is coming up on the screen. So allow me to share the screen. Screen visible?
Yes, sir.
Okay. So as you can see in the, where you can see, as you can see in this, there are satellites revolving around the sun, Earth, and they are transmitting signal towards the Earth. Our GPS receiver is receiving these signals, and from these signals, we are able to fix the position. Let us see how this is done. So first of all, we are going to talk the principle on which the position fixing is done. फिर हम आगे बात करेंगे जो थोड़ा सा अभी हमने इंडिकेशन भी दिया था कि सिस्टम क्या कॉन्फ़िगरेशन है, ये सैटेलाइट्स क्या होते हैं, क्या उनका रोल है, ग्राउंड सेगमेंट क्या है, उनका क्या रोल है, कैसे कंट्रोल ऑफ द सैटेलाइट्स आर डन, देन यूजर सेगमेंट्स. तो हम सिस्टम कॉन्फ़िगरेशन के बारे में बात करेंगे. We will take a closer look at what are the information transmitted by the satellites, on what frequencies it is transmitted, and how do we measure the range. That timing and ranging will come here. Then we will exactly find out how the position is fixed, how the speed is also fixed by the GPS receiver. It is determined by the GPS receiver. Some more topics that we are going to cover is that errors of GPS, important question. Like I have always repeated, a device does something for me. Very good. I should know about it, what it does for me. But then I should also know where it can lead me in a wrong direction. कहीं गलत तो नहीं बता रहा, और बता रहा है तो कितना और क्यों, so I can take my action properly. So errors. We'll talk about WGS, datum shift. Then some, some discussion on plotting the position of the GPS onto the chart. And finally, differential GPS. These are various subtopics of the GPS topic. We'll be taking a look at all of them. So just a read through. Just go through this. What we discussed is already here. So the GPS system is owned and operated by USA, as we already discussed. It has got some satellites, some 24 satellites up in the sky, which help us find our position. We'll talk more in detail about this space segment, about the satellites. We said that our GPS receiver is doing some kind of mathematical exercise, some calculations. There is a computer processor there. It will do some calculations on the basis of inputs received. The input is going to be the location of the transmitting station. In our case, it is the satellite. The satellites are transmitting signals, and my receiver is receiving it through the antenna, which is placed on the Monkey Island. So the two inputs, location of the satellite and the range of the satellites. Right now where I am, I don't know my position, but from me, the satellite is so much distance, or I am so much of distance from the satellite. Sorry. That means the range of the satellite. This mathematical exercise, which is performed in the receiver, is called trilateration. Basically, trigonometrical exercise. So the two inputs required are these. Please hammer it in your head all the way, because these 2 points will keep coming again and again throughout the topic. What are the 2 inputs required for GPS receiver in order to calculate position or take a position fix? Three known positions, come se come, and the distance from these reference points. Once these 2 informations are available, then we can proceed with our mathematical calculations. So now trying to understand the method, how the position is fixed. Right now you have a white screen and there is a blue dot. This blue dot is the transmitting station, for example. The white screen that you're seeing is a plane surface. Let us say the surface of the earth. On the surface of the earth, there is this blue dot, which is a station. Let us call this transmitting station. Station 1. Of course, this is transmitting signals in all directions. It is transmitting signals in all directions. In this transmission, it is transmitting information about its location. Station 1 अपना latitude longitude also transmits. I have a receiver somewhere. I don't know where. I may be here, I may be here, I may be here. Somewhere I am located. I have a receiver, so now I know the latitude longitude of station 1. Station 1 is also transmitting some kind of signals. With that, I can find out how much is the range. So with the help of the signals transmitted by the station, I can also find out how far away is the station from me, or vice versa, how far away I am from the station. So let us say, with the help of these 2 signals, I find out that I am located at a distance R1 from station 1. Now, what are the possibility? Where can I be located? If this is the condition that station 1 is at so and so latitude, longitude, and I am at a distance R1 from here, what is my possible location? Where can I be?
The circumference of the range, sir.
Very good. Circumference of the range, or on a position circle. Very good. I can be located on any point on this circle, position circle. Infinite number of possible positions. Not done. So what I do? I start looking for another station. I have another station which I am calling the station 2. Of course, this station also is transmitting signals, similar kind of signals, but station 2 is talking about its own position, not station 1, but station 2 ka position. And the other signal which it is transmitting, my receiver is able to find out the range. So range this time is R2. Forgetting about the first position circle, if we only take station 2 and R2, the possible location is going to be this. Is that correct or not? A position
Yes,
circle. Position circle having range R2 from station 2.
Yes, sir.
That means at this given point of time, I am R1 from station 1, R2 from station 2. What are the points or what are the possible locations from where these two conditions can be satisfied? Of course.
Where the position circle intersect.
Very good. So that infinite number of position has now been narrowed down to two possible locations, as you can see in the circle. I still don't know XY. Lat long I don't know, but I have the latitude longitude of station 1 and station 2 because of the signal that they are transmitting. So two possible locations now. Still ambiguity is there. I can be either here or there. I want to eliminate that. So what I do, I look for a third station, station 3. Station 3 also transmitting the same signals, and I find out that I am located at a distance R3 from station 3. That means at this very moment, I have to satisfy three conditions, as you can see on the screen. And this is the only place from these three conditions are satisfied. R1, R2, R3 from station 1, 2, 3 respectively. There is only one point from where these three conditions are satisfied. And so finally what we have is our position, which is at this place. Point of intersection of three position circles. This is where the position of the receiver is. In doing so, we had x1, y1 for this known location, x2, y2 known location for station 2, x3, y3. These are three known quantities. What I don't know is x and y for me. There are two variables, x and y, unknown quantities. I require three inputs to resolve them into an equation and try to find out the value of x and y out of these three equations. Of course, we are not going to do the whole equation or mathematical equation, but yes, we'll take a look at this कि ऐसा कुछ formula होता है. So this is what is called trilateration. When we take all these values and derive an unknown value, x and y, this process is trilateration basically. So this was what we were talking about when we were on the surface of the earth. On a plane sheet, we saw here, so position circle, here, position circle, here, position circle. On a flat surface, 2 dimension, latitude, longitude. But in GPS system, this station 1, 2, 3 are satellite 1, 2, 3, 4. And they are in the space. So if this is the satellite, if this is the satellite, and I am located 20,000 kilometers from here, from this 20,000 kilometers, what are the possible locations for me? Is it going to be a circle?
Yes, sir.
Circle, this circle or this circle or this circle or that circle. Which circle I am going to be on? I can be 20,000 kilometer here, here, everywhere I can be.
Yes, sir. Mean infinite, sir.
So it will be a sphere, right?
Sphere, yes, sir.
So 3 dimension में sphere हो गया, 2 dimension में circle था, plane surface, but now it is in space. So I can be 20,000 here, everywhere. I can be 20,000 kilometers away from the satellite, the center. If we take this from the center, if the radius of the earth is 6,000 kilometer, or is it diameter, whatever, from the center, the surface is all 3,000 kilometer from the center, all across. So if the center, at the center is the satellite, then I can be located anywhere on the earth, a sphere basically.
Yes, sir.
So with one circle, with one station, what we were getting as a position circle, now we are getting a sphere. दूसरे सर्किल, दूसरे सैटेलाइट से भी स्फीयर होएगा. Now suppose this is the sphere that we were talking about. The center is the satellite. The center is the satellite, and this is the sphere on which I can be located. I may be located. So if those two spheres are merging together to give a common point where they are entering into each other, what is the common point?
Where they will intersect.
So is it a point? Is it 2 point? Is it 5 point? Or is it some other kind of shape? When they are merging together, one ball getting into each other, what is the shape that you are getting? Common intersection point? Is it this?
Yes, sir. It will be like elliptical and
Not elliptical. अगर हमने ये किया तो ये कॉमन पॉइंट आ गया ना, सर्किल हो गया. इधर का और इधर का दोनों जब मर्ज कर रहे हैं,
यस सर,
अगर मान लीजिए आप 2 बलून हाथ में लेते हैं और 2 बलून को चिपकाते हैं, तो बीच में कॉमन वाला पॉइंट जो बनता है वो क्या बनता है?
प्लेन सर.
सर्किल बनता है ना?
हाँ सर, हाँ सर, एक सर्कल बनेगा, सर्कल बनेगा.
आउटलाइन जो होगा वो सर्किल होगा.
आउटलाइन, हाँ सर, सर्कल.
तो 1 से स्फीयर बना, 2 से सर्किल बना. अब जो वहां 1 से सर्किल बनता था 2D में, यहाँ 2 से मिला के सर्किल मिला मुझे.
और 3 से सर एक स्ट्रेट लाइन बन जाएगा फिर.
नहीं, जब एक सर्किल है, मान लीजिए एक सर्किल है, एक सर्किल आपको मिल गया, इसमें मैं एक दूसरा बॉल अगर इंसर्ट करूं तो कॉमन पॉइंट क्या मिलेंगे मुझको?
सर सर्कल मिलेगा, जहां इंटरसेक्ट करे एक सर्कल.
नहीं, ये सर्किल तो हो गया, 2 का एक सर्किल मिल गया, एक बॉल इधर, एक बॉल इधर, तो कॉमन पॉइंट तो ये हो गया. अब इसमें तीसरा बॉल घुसेगा तो क्या मिलेगा मुझको? एक ये पॉइंट, एक ये पॉइंट, यही दोनों मिलेंगे ना?
यस सर.
अगर मैं इसको कैसे करूं? अगर मैं इसको यहां से मिक्स करता हूं, एक सर्किल तो मिल गया, इसमें अगर मैं दूसरे सर्किल को पॉइंट करता हूं, तो हाउ मेनी पॉइंट्स आई एम गेटिंग? एम आई गेटिंग दिस एंड दिस?
यस सर.
So now with 3 satellites, how many common points we are getting? 2. एक स्फीयर, 2 स्फीयर, दोनों का कॉमन इंटरसेक्शन पॉइंट इज अ सर्किल. उस सर्किल में जब मैं तीसरा बॉल डालता हूं तो यहाँ एक पॉइंट, यहाँ एक पॉइंट, ये 2 पॉइंट कॉमन. So now if I want to eliminate the ambiguity, what should I do? Satellite number 4. So there will be a common point from where there will be 4 conditions satisfied at the same time. In this, the position of the satellites are not 2-dimensional. सिर्फ x y में नहीं है, but it is x y z. Altitude भी. So 3-dimensional position के लिए 3D position के लिए minimum of 4 satellites required. On the surface of the earth, if we are taking, already surface of the earth is a sphere. सैटेलाइट से अगर मैं सरफेस पे देख रहा हूं तो इसका जो प्रोजेक्शन होगा सैटेलाइट का वो तो सर्किल बन जाएगा. यहां से सैटेलाइट से जो सिग्नल आ रही है अगर मैं 20,000 तो 20,000 किलोमीटर का सर्किल बन जाएगा. If the satellite is here and I am located 20,000 kilometer on the surface, so 20,000 here, 20,000 here. I can be anywhere
Yes,
on
sir.
the circle.
Yeah, 20,000 circles, sir. Yeah, circumference.
20,000 from the satellite, it will be a circle. So,
Yes, sir.
if we are talking about the 2D position on the surface of the earth, तो एक ही सैटेलाइट से मुझको एक सर्किल मिल जाता है. क्यों? क्योंकि दूसरे स्फीयर का काम कौन कर दे रहा है?
Earth.
So for 2D position, we require only 3 satellites. For 3D position, we require 4 satellites. So this is the method of position fixing. This is how the GPS system is fixing the position. हो क्या रहा है? तो सैटेलाइट्स घूम रहे हैं अपने ऑर्बिट में, वहां से वो सिग्नल्स ट्रांसमिट कर रहे हैं. मेरा जीपीएस रिसीवर उन सिग्नल को रिसीव करता है. उस सिग्नल में उस सैटेलाइट का ऑर्बिटल इंफॉर्मेशन है कि कहाँ घूम रहा है. उस ऑर्बिटल इंफॉर्मेशन से मैं पता कर लेता हूं कि अभी यहाँ पे, अब वहां है, अब वहां है, अब वहां है. हर सेकंड का मैं पोजीशन पता करता चलता हूं. कौन? रिसीवर मेरा. With the orbital information, the receiver calculates exact position right now. Then right now, every second. तो सैटेलाइट का पोजीशन मिल गया. कैसे मिला? उसी सिग्नल से जो वो अपना इंफॉर्मेशन भेज रहा है, समथिंग कॉल्ड एफिमेरिस. आगे आएगा. Then it is also transmitting some other kind of information, something called pseudo random codes. उस कोड से पता करते हैं कि वो है कितनी दूर मेरे से. So 2 informations received from satellite 1, from satellite 2, from satellite 3, satellite 4. 4 satellites है XYZ, X1 Y1 Z1, X2 Y2 Z2, X3 Y3 Z3, X4 Z4, X4 Y4 Z4. 4 वेरिएबल्स मिल गया. मेरा अपना XYZ अननोन है. So doing this trilateration process, I am able to find out the values of X, Y, Z, which is my position. I find out latitude, longitude and the altitude. मैं जमीन से ऊपर कितना. 3-dimensional position can be calculated in X, Y, Z, latitude, longitude, altitude. Are we good?
Yes, sir.
Lalji, Lalit Saab, how are you?
I'm good, sir.
Are we getting somewhere? कुछ idea लग रहा है कि how is it going?
Yes, sir.
Okay. So अगले class में we'll meet and we'll talk about the space segment, the ground segment, and the user segment, which uses satellites to fix the position. We might add on the surface of the earth or near the surface of the earth. Say, for example, a helicopter is wanting to find out its position. Then it has to find out where it is, whether in India or America or which place, and also at what height from the earth. So, as we are leaving the surface, we are in the air, it is near earth. Not necessarily on the earth, but near the earth. So, it can give 3D position. The method of fixing position was trilateration, as we understood, a mathematical exercise, trigonometric, where if you know the three coordinates and if you know the ranges from these three coordinates of a third unknown coordinate or fourth unknown coordinate, it can be calculated. If you have x, y, z for three known places, or on the chart itself, if you see on the graph, if you have x, y, x, y, x, y of three known places, and if you take the ranges from these three to a common point, that x, y can be calculated mathematically, which is what is done by the GPS receiver, by the program which is installed in the system. All electronic equipment, microprocessors, computing is happening. Take anything, for example. Of course, computing is now not happening in communication devices like radio communication and all that. But otherwise, VDR, GPS, ARPA, AIS, all these things, there is some kind of computing happening. There are three major parts of the GNSS, and so it is the same with the GPS also. The GPS has got three segments, so to say, the segments of GPS. These are space segment, the ground segment or control segment, and third one is the user segment. In a GPS system, from start to finish, these three segments are involved. Each one will have certain kind of capability, certain role in the whole system. In general, the space segment is all about the satellites. There are 24 active satellites and 8 standby satellites. 24 active satellites and 8 standby satellites up in the sky. They are orbiting around the Earth in a circular orbit. These orbits are inclined to the equatorial plane by an angle of 55 degrees. Remember that there are 24 satellites and they are in 6 such orbits. There are 6 orbits, 24 satellites. So the logical conclusion is that each orbit will be having 4 satellites. 6 into 4, 24. All these 6 orbits are inclined to equatorial plane by an angle of 55 degrees. What do we mean by that? So if this is the Earth, this is the equatorial plane. ये equator है. This is the equatorial plane. The orbits are like this. So the orbit is inclined to the equatorial plane by 55 degrees. This is the plane of the orbit. Another orbit is like this. Another orbit is like this. 55 degrees, 55 degrees, 55 degrees, 55 degrees. These satellites are up there at a height of 20,200 kilometers from the surface of the Earth. What is known as the medium Earth orbit. आपने LEOSAR का नाम सुना होगा, Low Earth Orbiting Search and Rescue Satellites. तो वो lower orbit में रहते हैं. There is medium Earth orbit and outer orbits. So the range from 1,000 kilometers to 36,000 kilometers is known as medium Earth orbit. They lie there. All the satellites are there. So height of the satellites 20,200 kilometers. in 6 orbits, these 24 satellites. They are moving in their orbits at the speed of 3.9 kilometers per second. 3.9 kilometers per second. With this speed, they take about 11 hours 58 minutes, half of the sidereal day. They take 11 hours 58 minutes to complete one orbit. घूम करके आते हैं something like 11 hours 58 minutes, or you can simply say 12 hours. जैसे हम लोग दिन के बात करते हैं, दिन 24 घंटे का होता है, वैसे you can say half a day. So can you tell me on which place, I mean on the same place on the earth, after how much time the satellite will be coming back? हाँ जी,
12 hours, sir.
क्यों? यहां से शुरुआत किया, ये जब घूम के 12 घंटे में आया तो 12 घंटे में अर्थ ऐसा नहीं हो जाएगा?
Sir, सही बात. So plus rotation of the earth.
हाँ, तो वो वाला पॉइंट जो यहाँ पे था, ये तो 12 घंटे में घूम के आया यहाँ पे, लेकिन बीच में अर्थ ऐसा घूम गया ना, तो ये वाली पॉइंट तो उल्टे तरफ चले गई.
हाँ सर.
तो अब क्या होगा?
टाइम इंक्रीज कर जाएगा.
24 घंटे में एक बार होगा.
24 घंटे लगेंगे ना?
हाँ सर, 24 घंटे.
यहाँ से शुरुआत किया, ये घूम के आया तो ये चला गया इस तरफ को, फिर दोबारा घूम करके आया तो फिर ये घूम के वापस आ गया, तो दोनों फिर से मैच कर गए. So every 24 hours, the satellite, given satellite, is at the same point on the earth. Now the placement of these satellites, 4 satellites in each orbit, is such that from any point on the earth at any given time, at least 6 satellites are visible. Minimum 6 satellites are always visible. Minimum. Maximum 12. Remember that if there are 6, some of the satellites are this side, some of them are on the other side of the earth, which will not be visible. So this side, minimum of 6, maximum of 12 satellites are visible at any point on earth at any given time of the day. And that is why it is a global system. Globally, you can fix your position, be it on poles, be it on equator, be it on any intermediate latitude. All the time you can get the position, and that's the name. That's why the name GPS, Global Positioning System. All these satellites, since they are moving in the orbit, it is possible for them to get away from the orbit, deviate from the orbit, which is not required, which is not wanted. They must remain in the same orbit. तभी तो वो repetitively पोजीशन फिक्सिंग में पार्टिसिपेट करेगा और हमें मदद करेगा. अगर इधर उधर हिल गया तब तो बात गड़बड़ हो जाएगी. So to keep them in the orbit, they also have a propulsion system. That means they can be maneuvered in the space. अगर इधर को जा रहा है तो इधर लेके आ जाओ, इधर जा रहा है तो इधर लेके आ जाओ. So navigation जो हम करते हैं, if we go port starboard of the land track, then we pull it back by giving helm. ऐसा ही वहां पे होता है. So they also have this propulsion system which can be operated remotely by the ground staff or ground stations. That means all the satellites are controlled by stations which are located on ground. Not only controlled for their movement, but also the satellites, what are they going to transmit? The data which is used by the user to fix position is transmitted by the satellite, but where do they get it from? अपने आप से तो होएगा नहीं. That also is uploaded by the ground antennas or ground segment. अभी थोड़ा डिटेल में हम ग्राउंड सेगमेंट के बारे में बात करें. All these satellites have got antennas and a solar panel. Solar panel to obtain energy from the sun. So as the satellite is moving in the sky, their solar panel is always oriented towards the sun. जिधर भी जाते हैं तो they always keep oriented towards the sun in order to obtain maximum energy. The antenna which is transmitting the signal for position fixing has to be towards the earth, क्योंकि सारे users तो earth पे हैं या earth के नजदीक हैं. So antenna is automatically oriented so that the maximum transmission is happening towards the earth. So these are few facts about the space segment. Remember that the satellites are transmitting signal for the GPS receiver. GPS receiver is receiving those signals and doing the fixing of the position. But it must be uploaded to the satellite by somebody on the ground. Do you think that if you have made a system, a constant monitoring is required? That okay, सब कुछ ठीक ठाक चल रहा है कि नहीं, बना दिया, लेकिन उसके ऑपरेशन के लिए, उसके मेंटेनेंस के लिए कांस्टेंट मॉनिटरिंग चाहिए होगा. Such is the case with the GPS also. All these satellites must be monitored continuously. If anything is observed, if everything is fine, good. If anything is observed which is not right, those corrections have to be done. Who will do the correction? Again, people on the ground. So next comes the ground antennas, ground segment or control segment. Space segment is all about the satellites. Ground segment or control segment are the people on Earth who are watching these satellites, putting them in place, giving them data to transmit back to the Earth, and constant monitoring. We will go to the slides. वहां पे देखेंगे, वहां पे थोड़ी सी बात करेंगे हम. Allow me to share the screen. Just 1 second. Let me open the file. All right. All right, so trial accuracy के बारे में हमने कल देखा था. These are the 4 satellites required in order to fix 3D position, 3-dimensional, latitude, longitude, altitude. The point here is the intersection point of all these 4 spheres, which are the spheres of the position spheres of the satellites with a range as is calculated by the GPS receiver. Okay. the segments. Take a look at this. This is the general arrangement of this three segments. You have first the space segment, which is all about the satellites. You have control segment or ground segment, which is consisting of master station, monitor station, and ground antennas. So control segment is consisting of these three subparts: master station, monitoring stations, and ground antennas. And then there is this third user segment, which is you and I, who have GPS receivers. Our GPS receivers give us this position. Please study the diagram and take a look at the flow of the data, the arrow, the transmission reception, who is who, and who is transmitting to who. ग्राउंड सेगमेंट और कंट्रोल सेगमेंट के बारे में हम बात करेंगे, बट बिफोर वी थिंक, just one line about this. Master control station is the heart and soul of the GPS system. Everything is done from here itself. It is the command center of the whole of the GPS system. Master station only decides where the satellite should be, what should be transmitting, what should they be transmitting, if any correction is required, if there is some satellite has gone wrong, so that has to be discarded and new satellite to be brought into action. Everything is done by the master control station. But master control station cannot be all over the world. There has to be one place, which is in Colorado Springs Air Force Space Station पे. Of course, इसका alternate भी available है in California. So master control station is the decision-making body. Since it is located at one place, so it will be able to monitor only those satellites which are visible in the sky right now. But remember that minimum of 6, maximum of 12 only can be visible from any point. So right now master station is looking, let us say, at 8 satellites. So 16 kahan gaye? They will be elsewhere behind the earth. Now how will it be monitored? How will those be monitored? The 16 which are not visible. For that we have monitor stations. That means, as the idea would say, these monitor stations are spread all across the world. You might think ये तो यूएस सिस्टम है, दुनिया में बाकी लोगों को क्या करना? तो गवर्नमेंट्स के बीच में कोलैबोरेशन होती है, पॉलिसीज बनती हैं. So there are so many states which are, or countries which are friendly to USA. तो उनके आपस की डील हुई, उन्होंने अलग अलग जगह पे ये मॉनिटर स्टेशंस लगाए. When the master station thinks that a new data has to be uploaded to the satellite, it can send them directly whatever are visible. To the visible satellites they can send directly, but the satellites which are not visible is sent via the ground antennas, which again are located at different places on Earth. 4 of the ground antennas, which covers the entire sphere or entire constellation of the GPS satellites. Of course, we know that the GPS receiver is only receiving the data, no transmission. So take a look and study the data flow. Is it making sense or not? Is it okay?
Yes, sir.
All right. Also remember, reminding you early on that the satellites are transmitting signals, two kinds of signal, or rather are two kinds of information. Not only two kinds of information but also on two frequencies, जो कि अभी आएगा इसके बाद. So let us take a look at the function of the three segments. Just go through, repeat होएगा, but just go through it. Next 15. Next. Next. Slide 18. The solar panel facing the sun, the transmission happening towards the earth. Next. So you have an animation which shows the number of visible satellites. They keep changing as the satellites are orbiting in their orbit. The blue dot on the earth is the place where the GPS receiver is. The black ones are visible satellites, the red ones are not visible. See, the number here does not go less than 6, does not go more than 12. Same is the case with the solar panels, which are always turning, you see, in such a way that they are facing the sun. visible satellites connected with red line. So this is the space segment. The ground segment or control segment is consisting of these three parts. This is master control station, monitor stations, and ground antennas. If I want to send some signal to the satellite, I will need antenna to project the transmission towards the satellites. So ground antennas are those antennas which is used to transmit data to the satellites. Monitor stations are scattered all over the world, which constantly receive signals from the satellites. These signals will consist of the height, altitude, that is their position, their movement, their path, their health condition. All those informations are received by the monitor station, and it is passed to the MCS, master control station. The master control station will analyze all of the data and see if the satellites are in the place, if they have valid data which they are transmitting. Remember one thing, the satellites are transmitting some information about their position. It is possible that they are somewhere and telling somewhere else. जैसे मैं यहाँ बैठा हूँ इंद्रपुरम में और बोलो कि मैं दिल्ली बैठा हूँ, मे बी नॉट नोइंग वेयर आई एम. सैटेलाइट्स को तो पता नहीं होगा कि मैं कहाँ हूँ. So this monitoring and assessment has to be done by the master control station. So there can be two things. If the satellite is moving in the orbit like this, probably it is transmitting data about a path which is this. The data is transmitted about this green path, but actually it is on the red path. This can lead to error. This situation can lead to error, which we will learn, and we have already learned something called orbital error. What they are what they are transmitting about their movement is not what they are doing actually. They are somewhere else. This is the condition in which either the data has to be changed for this place or their path has to be brought back onto the green one. They must match. Who will analyze this? Master control station. Who will correct this? Master control station. How will it correct? By transmitting signals, control commands from the MCS. How will this commands be reaching the satellites? Through the ground antennas. So read through this and see if there is any problem in what we are reading. So main master control station is located in Colorado Air Force Base. There is also an alternate master control station. अगर कुछ हो गया एक जगह यहाँ पे तो कम से कम वहां से ऑपरेट कर सके. फॉल बैक ऑप्शन, जैसे हमारे जहाज में 2 एक्डिस होता है, 2 सैटसी होता है, 2 VHF होता है, वैसे यहाँ पे भी 2 MCS है. Now there are some new terms which are coming up here. MCS uploads all pseudo random codes and navigation message to the satellite. These are the data, the information that we are saying, pseudo-random codes and navigation message. These are the information is first uploaded by the MCS to the satellite, and then satellite will transmit it back for the users. The user will receive this and fix the position. This will be a common sense understanding that if the input data is not right, the output will not be right. That means these data have to be correct. And so it is monitored all the time. In this two information, the pseudo-random code is used for finding out the range of the satellites. Pseudo-random codes are used for ranging purpose, finding out the range of the satellite. Navigation message is giving the position of the satellite, but not directly. Satellites are not transmitting their position per se. They are transmitting their orbital information, their movement, speed, etc. And with this movement, the GPS receiver is fixing or extracting their current location. Abhi kahan? Ab yahan, ab yahan, ab yahan, ab yahan. So for every fix that the GPS receiver is obtaining, it finds out exact location of the satellite. So those things will be in the navigation message, which talks about their orbital movement, their location, etc. Pseudo-random codes are used for finding out their range. तो थोड़ा सा डिटेल में और बात होगी इन सब के बारे में. We'll talk more about pseudo-random codes. We'll talk more about navigation message rather in detail. Next, 25. The monitoring stations. As we said, monitor stations are spread all over the world so that all 24 satellites can be monitored on a regular basis, on a continuous basis. Some of these monitor stations are in direct control of the US Air Force. They have their bases in so many countries. There are so many places which are in control of the US government. So they have placed their monitoring stations in those places. Like Colorado Springs itself, Hawaii, which is a US territory, Cape Carnival, Florida, Ascension Island, Diego Garcia, Wasland Island. These are the places which is in control of the US government, and they have installed monitoring station at this place. But there are other places also which is not in direct control of the US government, but they have worked out a deal with the country, given country, and so the other countries have allowed them to install their monitoring stations. These other stations are co-located with something called NGA. NGA bases are there, something called National Intelligence Agency, Geospatial Intelligence Agency. You know, like US is keeping eye on the world all the time. They are monitoring what is happening, where it is happening, how it is happening, and it is all done through the satellites. So satellite की images हैं. अभी शायद आपने सुना होगा कि कुछ पिक्चर US गवर्नमेंट से हमें मिली थी डोकलाम के बारे में. हम अपनी मॉनिटरिंग जो करते हैं,
Yes,
करते हैं बट यस, डोकलाम में जो इश्यू हुआ था चाइना के साथ, उसमें कुछ मूवमेंट जो चाइनीज ट्रूप्स के हो रहे थे, those pictures were released by US government also. Maybe Indian government is working closely with them to obtain more information. So like that, US has got so many of NGA bases in so many places. So this GPS monitoring station is also located with them. And they are located mostly in other countries. Alaska, Australia, Bahrain, Argentina. Washington में एक तो है, which is definitely NGA station, but not direct in control of the Air Force. Ecuador, United Kingdom, South Africa, South Korea, New Zealand. So as of now, as we know, there are 17 monitoring stations, 6 of them Air Force, 11 of them NGA monitoring stations. This is what it looks like. A monitoring station, nothing but consisting of an antenna which is collecting data from the satellites, and they will be of course connected with the MCS through internet and all that. So data is passed on to the MCS through other means. Next, 28. As we said, minimum of 12 satellites are visible. So here it is saying 11. So each monitor station will be obtaining data of 11 satellites and be monitoring them twice daily, because the satellites are passing twice daily. So दो बार observation होती है. Data is of course passed on to the MCS. Slide 29. So here is a new term being coined in this slide. The term is atomic clock, which is part of the ranging procedure by the GPS receiver. How do we find out the range? We find out the range in general. Distance is equal to speed into time. In general, we find out how much time a signal is taking from satellite to the GPS receiver. कितने टाइम में पहुंचा है ये पता करते हैं. Multiplied by the speed of the signal, that is the radio waves, gives us the range. So atomic clock is a clock which is providing time to the accuracy level of nanoseconds. If there is difference in the time, the range will be different or wrong. So it is important that the clocks are perfect and the range that we obtain based on that time has to be accurate for position fix. Then there is another term which is being coined here, is ephemeris. There is another term which is almanac. Rather, all these three are combined in one kind of message transmitted by the GPS satellite, what we call the navigation message. पहले आया था navigation message, we said in the navigation message there are orbital information, their location, movement of the satellites. So almanac and ephemeris are those two information which gives their movement in the sky, out of which, from which the GPS receiver is able to calculate position of the satellite. Remember, there were two inputs required for the GPS receiver: known locations and the range. All this data will be uploaded by the master control station at given intervals. Make a note here that ephemeris is uploaded every 2 hours. Almanac is uploaded every 6 days. Why and how, we will understand once we start talking about this in the latter part of the discussion. The ground antennas. Already talked enough about this. Just read through this. Only one thing that you should note here, that when the signals are transmitted, it is transmitted on S-band frequencies. S-band क्या है? Of course, you remember hearing this earlier. S-band.
Yes, sir. 9,000 kilohertz.
9,000 kilohertz.
9 gigahertz. 3 gigahertz.
3 gigahertz. 3,000 megahertz.
Is good.
Basically, S-band is 2.9 gigahertz to 3.1 gigahertz per radar. It is this range of frequencies only which is also used to transmit data to the satellite. We know that range of the radar is 100 miles or so maximum, जब maximum limit में जाते हैं तो, but actually it is line of sight communication and we can transmit data long distance. बट जो लिमिटेशन रडार की हो जाती है वो कर्वेचर के चलते हो जाता है, यहाँ से ट्रांसमिट किया तो यही तक हमें मिलता है डेटा, हम यही तक टारगेट को मॉनिटर कर सकते हैं, बट द सिग्नल कैन ट्रैवल लॉन्ग डिस्टेंस. सेम इज द केस विद VHF आल्सो. VHF 30-40 miles. VHF 30-40 miles because it will go straight, but if there is a satellite it can receive VHF very nicely, which it does. बहुत सारे सैटेलाइट्स हैं जो VHF कम्युनिकेशन भी करते हैं. So read through next. So these are the 4 places where ground antennas are there. These 4 antennas cover the entire celestial hemisphere where these satellites are, moving in their orbits. Next, this is the map of the ground antenna, ground segment or control segment. Just to give you an idea, where is what? You can take a look at this legends. Red star, master control station. Yellow star, alternate master control station. These are the 2 types of monitoring station that we talked about. In control of Air Force, in control of our NGA monitoring stations. and this green triangle is ground antennas. So you can take a look. Four antennas are able to cover the entire world for transmission. A world rather, the celestial hemisphere, the skies. There are these purple dots which are NGA monitor stations. There are blue dots which are Air Force monitor stations. And of course, there is this MCS, the red one and the yellow one. Finally, the user segment. We have seen what GPS receiver is, many of them, many types, many companies, manufacturers. They all make GPS receivers, which we have either in our pocket in mobile phones, or there are other devices like what we have seen on board ship. In general, it will have this screen, a box in which there is all electronics, and an antenna either attached to this device or separate antenna on the Monkey Island, as we have seen on the ship. If we place the antenna in the Monkey Island, it is able to see the skies very clearly, and so the performance of the GPS receiver will be good. If you stay indoors, there may be a little bit of error. So it has got screen, few buttons, microprocessor, that is computer inside, an antenna. Additionally, there is also a clock inside. This clock is used to find out the range of the satellites. Remember, range or distance is equal to speed into time. So the GPS receiver needs to have very accurate kind of time. There should not be error. So this is the user segment. Now what happens when the receiver is switched on? When the receiver is switched on, it locks onto the one satellite. There are so many satellites in the sky. It will start receiving signal from any one satellite. किसी एक से पहले data download करेगा. Remember, the satellites are transmitting some signals, so it is beginning to receive them. और इस सिग्नल में almanac होता है. वो बताता है कि कौन कौन से सैटेलाइट्स विजिबल है. सो almanac से रिसीवर को पता चलता है कि कौन कौन से विजिबल सैटेलाइट्स हैं मेरे पास, अभी होंगे. उसमें से बेस्ट सूटेड सैटेलाइट को सेलेक्ट करके और उनसे रिसीव करना शुरू करता है सिग्नल. So any one satellite is transmitting almanac. The almanac is the information about the whole constellation of GPS satellites. Almanac में all information is there about the 24 satellites, about their locations and all that. That means किसी से पूछूं, किसी से भी रिसीव कर लूं, तो almanac सब में कॉमन होगा, जिसमें ये बताया कि मैं यहाँ हूं, बाकी सारे 23 are scattered in these places now. So if I ask satellite number 2 or 13 or 18 or 21, all are giving me the almanac. और जब भी almanac मैं रिसीव करता हूं तो सारे सैटेलाइट जो विजिबल है उसका पता चल जाता है मुझे. Then it will select the best suited satellites for position fixing. and it will start giving you the fix. But remember one thing. This is about 24 satellites. The almanac is all about 24 satellites. Also remember that almanac is uploaded every 6 days. तो 6 दिन में तो क्या से क्या हो जाएगा, सैटेलाइट कहीं की कहीं पहुंच जाएगी. So the precise information of the satellite movement is individually received from each satellite, and that is called ephemeris. On board ship, we have had navigation publication called almanac, nautical almanac. क्या information होती है उसमें? What do we have in the nautical almanac? Yes, sir.
GHA declination every hour.
Information about the stars, planets.
Planets, sun, moon.
Okay. That means it is generally talking about all available stars and planets जिससे आप navigation करते हैं. Similarly, almanac here also doing the same thing. It is talking about the whole constellation. There are information about all the 24 satellites. But there is also ephemeris, which is each satellite is talking about its own ephemeris. This is what I am doing right now. This is how I am moving. Satellite A is in this line, or A to 1 बोल देते हैं. Satellite number 3 moving like this. Satellite number 21 moving like this. Ephemeris data is the exact navigation of the satellite in the sky. And to find out the range, we need to know exact position of the satellite. Of course, that will be derived from ephemeris data. Read through. जब हम रिसीवर को ऑन करते हैं तो सारे सैटेलाइट से एक साथ सिग्नल नहीं रिसीव करते, किसी एक से रिसीव करना शुरू करता है और एल्मनेक डाउनलोड कर लेता है. एल्मनेक से पता चलता है कौन कौन सैटेलाइट विजिबल हैं और उसमें भी कौन कौन से सैटेलाइट्स आर सूटेड फॉर मी. व्हाई वी आर सेइंग सूटेबल? सैटेलाइट है, ट्रांसमिट कर रहा है, तो इट शुड बी सूटेबल. But no, two satellites which are visible, giving me good signals, may not be good for my position fix. That we can understand from an example. If we are here located somewhere here, it is our ship. If I take position fix by radar, should I choose two objects like this? To take the range bearing, should I take two objects like this? Or should I take objects like this? Or orange one? दो ऑब्जेक्ट को ऐसे ले या ग्रीन वाले को ले जो नजदीक नजदीक में?
थोड़ा orange ones.
What happens if they are far apart? The angle of cut is going to be good. Point of intersection we will find which is more defined, and we will get right kind of position. But if we take something like this from here, if we take from here to here, the intersection will not be good. So something of this sort happens, due to which the best suited satellites are selected and not suitable satellites are not selected for position fixing. So this is user segment. The maritime GPS receiver by default shows you the screen in which there is position, there is speed, there is course, and of course date time. Then you have certain bit of buttons which can be used to find out other information on screen. Default में इतना दिखाता रहेगा. So these are the segments of. We also have understood now that the satellite on these frequencies are transmitting some kind of data. What data is transmitted? One is called pseudo-random code. One type of data which is transmitted is called pseudo-random codes. We also have discussed that these are the codes used for finding out the range of the satellites. To find out the range of the satellite, इन दोनों के बीच में कितना distance है, that is done using this pseudo-random codes. Other information which is transmitted is called almanac. Something called ephemeris. And there are also clock corrections. So these are the type of data which is transmitted by the satellites. Pseudo-random codes and almanac, ephemeris, clock corrections. शुरुआत में हमने देखा था कि एक नेविगेशन मैसेज आया था हमारे डिस्कशन के बीच. So this information is transmitted in a special type of format which is known as navigation message. So there is pseudo-random code, there is navigation message. The navigation message will consist of almanac, ephemeris, and clock correction also. Pseudo-random codes for ranging these data for finding out the exact location of the satellite. Iska location will be found out with the help of navigation message. That range will be obtained using the pseudo-random codes. So we will see specifically what are the pseudo-random codes and the structure of almanac and ephemeris, or rather navigation message. So when we say like this, there are pseudo-random codes which are of two types called CA code and P code. The pseudo-random codes are two types, CA code and P code. What we call this as course acquisition ACQ. Course acquisition code, and this one is the precision code. the two types of codes which are transmitted by the satellites, which are CA code and P code. This code is used by the civilians. This code and also this code, CA code plus P code, both together is used by the defense services. You know, the Air Force, Navy and all that, military. What is the difference between this CA code and P code? That is hidden in the name itself, Force Acquisition Code and Precision Code. Can you see the spelling of the course? COARCE. It is not COURSE. It is not the heading we are talking about. Somebody please tell us the meaning of course. COARCE उसका मतलब बताइए जरा.
It means inferior quality.
Come again.
Something of inferior quality.
A kind of, yes. Coarse means rough. Coarse means rough. So if we say the wall is little rough surface, this is fine surface. So you've got it correct that it is of inferior quality, but this inferior is also just good enough. Standard जो मिलना चाहिए एक standard quality का signal होता है. So this is rough, this is precise, this is not so accurate, this is very accurate. And so the service provided by CA code is known as SPS, Standard Positioning Service. The CA code provides us something called SPS, Standard Positioning Service. The P code, on the other hand, provides something called PPS, Precise Positioning Service. So now from here, we can now understand we on board ship and user as a general, which kind of service we are using?
Sir, CA code.
That means SPS. CA code we are using, yes, but the service that we are making use of is SPS. GPS दो तरह के सर्विस प्रोवाइड करता है, SPS and PPS. SPS for civilians, PPS for defense services. Concept clear है?
Yes, sir.
All right. तो दो तरीके के सर्विसेज जो होती हैं GPS के द्वारा, these are the two types of services provided by the GPS system. Remember that these are pseudo-random codes and these are used for what purpose? बहुत बार repeat किया हमने. Pseudo-random code is used for what? What is the use of pseudo-random code?
Sir, to provide range.
To provide range, to obtain the range. That means SPS and PPS is basically a function of accuracy of the range that we find out. अगर रेंज हमारा प्लस माइनस हुआ तो हमारी पोजीशन सर्किल जो थी यहां बननी चाहिए थी. दिस इज द करेक्ट रेंज. अगर गलत रेंज मिला तो हमें सर्किल ये मिलेगा, पोजीशन यहां निकलेगा, यहां नहीं निकलेगा. So the level of accuracy is just a matter of finding out exact range. So PPS में कुछ ऐसा प्रोवाइड होता है कि defense services are able to obtain better accuracy of the range of the satellites, while we have little bit of plus minus. इसीलिए हमारा 10-15 मीटर इधर उधर होता है पोजीशन, जबकि डिफेंस सर्विसेज वाले को उस घर के उस फ्लोर में उस खिड़की में बम फेंकना है, तो प्रिसाइज पोजीशन तो चाहिए ही। थोड़ा सा इधर थोड़ा सा उधर हो जाएगा तो मामला गड़बड़ हो जाएगा। So these are two types of codes, or rather pseudo random codes. The navigation message, on the other hand, is consisting of almanac, as we have already talked about, ephemeris, and clock corrections. Navigation message में ये तीनों चीजें होती हैं। इनसे हम लोकेशन पता करते हैं सैटेलाइट का, इससे क्लॉक अपडेट करते हैं। So we will talk a little bit more about the necessity of clock correction. थोड़ी देर में भी बात करते हैं। But we must also understand, or should know, that on L1 frequency what data is transmitted, on L2 what is transmitted. हमने जनरल तो देख लिया था कि ये सब सारे डेटा होती है, but specifically किसमें क्या डेटा होता है। So L1, which is 1575.42 megahertz and 1227.6 megahertz, this is consisting of CA code, PE code, and navigation message. L1 पे ये तीन चीजें आती। On L2 there is only P code and navigation message. So do you think our ship GPS receiver is working with L2? हमारा रिसीवर क्या L2 रिसीव करेगा?
No, sir, L1.
क्योंकि इसमें CA कोड तो है ही नहीं। तो normally civilians are working on this one frequency, but the defense services का जो GPS receiver होगा, which will be special type of receiver, will be able to receive on both the frequencies. They will be using this as well as this. So there is dual frequency receiver, there is single frequency receiver. IMO performance standards पे जाएंगे for the shipborne GPS navigation system or GPS system. It is required to receive L1 frequency from the GPS satellites only, not the L2. Of course, plus GLONASS के frequencies also. दोनों ही frequency GPS and GLONASS दोनों की frequencies को use करता है. We have more number of satellites available. In general, we get better accuracy of the position. So these are the data transmitted by the satellites on the two carrier frequencies. Are we good here?
Yes, sir.
Remember that these codes are basically a digital signal. The CA codes and etc. are digital signals, basically 0 and 1 की form में. These are digital binary codes, CA code भी, P code भी, navigation message भी. All are डिजिटल इंफॉर्मेशन, जैसे हमारे डीएससी में होता है। डीएससी में क्या है, तो यहाँ पे हम जो लिखते हैं अपना पोजीशन और टाइप ऑफ nature of distress, etc., all this gets converted into binary code and it is transmitted, and back again the same thing is repeated as position, fire, etc. What we transmit is what is received, but in the middle there is digital information. Same way, CA code, P code, navigation message, all are digital data. Whenever we talk about digital information, immediately comes to the mind speed. एयरटेल का आप ब्रॉडबैंड कनेक्शन लेंगे, आपको 599 का प्लान मिलता है, उसमें बोलते हैं यू विल गेट द स्पीड ऑफ 40 Mbps। 800 का प्लान लेंगे 799 का, तो you will get 100 Mbps. If you pay 3,000 rupees, you will get 1 Gbps. What is this Gbps and Mbps? What is this? These are the speed of transmission. That means how many bits? 1, 2, 3, 4, 5, 6. How many bits in 1 second? That is the speed of the transmission. Why we are talking about this? Because we are going to talk about CA code. तो speed का information आएगा, reference आएगा. When we talk about CA code, P code and navigation message, तो सब में digital data है, सबके साथ speed होती है, अलग अलग speed होती है. One more thing we should understand, that when we have a carrier frequency, we have an audio signal, like I am speaking in the microphone, mayday, or banana port control, whatever. So these two are getting mixed together. Both are joined together or mixed together in a method which is known as
modulation.
Very good, modulation. And we also know that these modulations are of various types, like amplitude modulation, frequency modulation, and there is also something called phase modulation, and there are something called pulse modulation, and there are various subtypes of this. The GPS is using this phase modulation. So the CA code, the digital data, is superimposed on L1 and L2 frequency by phase modulation. So a few facts about the CA code. Of course, this is binary data. Transmitted in the form of 0 and 1. Speed of the transmission is 1.023 Mbps. That means 1 megabits per second. How many zeros and 1? 1 MB 0 and 1s. 1 mega means 10 to the power 6. What we call here as bits, in the GPS terminology, these are known as chips. The zeros and ones are known as chip. this chip will have a length. अगर हम 1 सेकंड में 10 to the power 6 डेटा ट्रांसमिट कर रहे हैं, in 1 second we are transmitting these many. So how much time will be taken to transmit 1 bit? और इसको उल्टा अगर करते हैं हम, these many bits are transmitted in 1 second. Then 1 bit will be requiring how much of time?
1 by 10 to the power 6.
That is 10 to the power minus 6,
Yeah, 10 to the power minus 6.
which is a microsecond. So the chip length is of 1 microseconds. Because 1 सेकंड में 1 MB होता है, तो एक चिप का लेंथ इज 1 माइक्रोसेकंड. We also know that in 1 second, the radio waves is traveling how much of distance? In 1 second, the radio waves, they travel how much of distance? 3 into 10 to the power 8 meters. So in 1 microsecond, how much of distance? Distance is equal to speed into time.
3
Correct?
into 10 to the power 2.
Of course. So this is 300 meters. So this is the speed, 3 into 10 to the power 8 multiplied by 1 microsecond, which is 10 to the power minus 6. ये हो गया 2, something 300 meters. So in terms of the length of time, the chip length is 1 microsecond, which is equivalent to approximately 300 meters. There is little bit of difference of speed, so it is 293 meters actually. So these zeros and ones are the building blocks. इसी से सारा information बनता है. And we are talking about the CA code. So CA code will not be 0 and 1, but number of zeros and 1 will be making one CA code. There will be certain number of data required to make one code. So how
Yes.
many bits are required? 1, 0, 2, 3 chips make one CA code. One complete code, to form one code, how many chips are required? 1, 0, 2, 3. One bit was 1 microsecond. So something like 1000 will make how much of time? How much time will be required to transmit this? For 1 bit, it was 1 microsecond. So time required to transmit one CA code will be this into 1000, something like this.
Yes. Sir.
But microsecond is 10 to the power minus 6. So the time required to transmit a code will be how much?
10 to the power minus 3
That is millisecond.
millisecond.
Very good. Very good. So the CA code length is 1 milliseconds, which is also can be converted into time, distance. So as we have already seen, 1 microsecond is 293 meters, roughly 300 meters, 300 into 1000, 300,000. So approximately 300 kilometers, 299.57 or something. of course, we have known that these binary codes are superimposed on L1 frequency by means of phase modulation. So there is phase modulation also. So L1 पे phase modulation से binary codes in 0 and 1 called chips transmitted at the speed of 1.023 Mbps. The chip length is so much. These many chips make one CA code. One CA code length this much or this much. In terms of time, 1 millisecond. In terms of distance, approximately 300 kilometers. Now we must understand that there are 24 satellites. There are 24 satellites. These 24 satellites all have different CA code. हर सैटेलाइट का अलग कोड होता है. So in the GPS receiver, can I rub it off?
Yes, sir.
और कोई जवाब नहीं देता. Not that I'm not happy, but others also should participate in the discussion. All satellites have different or unique CA code. If I have the receiver जिसमें 1 to 24 का कोड पहले से मेमोरी में है और मैं एक कोड रिसीव करूं CA कोड, तो मैं आइडेंटिफाई कर सकता हूं कि नहीं कि ये नंबर 9 का कोड है. So CA code is used to identify the satellite. The receiver, when it receives the code, it can identify, okay, this is satellite number 9. Okay, this is satellite number 22. Okay, this is satellite number 13. So the CA code is used to identify the satellites and also for what? Ranging purpose, to find out the range of the satellites. Are we good here?
Yes, sir.
So these are few facts which has to be mentioned when you are asked to write short notes on CA code. CA code is a pseudo-random code transmitted by the satellite for the users to find out the range of the satellites, which will be used for position fixing by the GPS receiver. These codes are binary codes which is transmitted or superimposed over L1 frequency by means of phase modulation. These binary codes, the zeros and one, known as chips, are transmitted at the speed of 1.023 Mbps. Then you talk about chip length. A chip length is 1 microsecond or 293 meters. You say 1023 chips make one complete CA code. The complete CA code is of 1 millisecond, which translates to 300 kilometers approximately. Each satellite has separate unique CA code with which satellites can be identified. These CA codes are also used for timing and ranging purposes to find out the range of the satellite from the user, which will be used for position fixing using trilateration method. Yes, sir. Are you good?
Yes, sir.
Sir,
Then-
one question.
हाँ बोलिए.
The CA code only covers ranging, so what's coming in the timing section? Timing should be in the NAM message, right?
ओके ओके. तो रेंज जो हम कैलकुलेट करते हैं, ओके, हम लोग पी कोड पे आएंगे. मान लीजिए अभी आपने पूछ दिया तो पहले रेंजिंग बता ही देते हैं कि रेंजिंग होती कैसे है. फिर हम पी कोड को कंपेयर करेंगे सीए कोड से कि इसमें क्या डिफरेंस होती है. ऐसे ही 2-4 पॉइंट्स है उसमें, ज्यादा नहीं. इसमें भी चिप्स होएगा, इसमें भी स्पीड होएगी, इसमें भी लेंथ होएगा, वगैरह वगैरह वगैरह. So how the ranging is done? How timing and ranging is done? Here is the satellite which is transmitting CA code. CA code is a digital data. These signals are coming here on L1 frequency, for example. The receiver here receives the signal. The first step is to synchronize the clock of the receiver with the satellite clock, so that both are having the same time. सैटेलाइट क्लॉक का टाइम और आपके जहाज का घड़ी का टाइम और रिसीवर का टाइम शुड मैच. कैसे मैच होगा? तो यहां से सिग्नल्स आती है, करेक्शन सिग्नल्स, टाइम सिग्नल्स आता रहता है और हमारा क्लॉक अपडेट होता रहता है, इसके साथ मैच करता रहता है. रिमेंबर, नेविगेशन मैसेज में हमने कहा क्लॉक करेक्शन भेजता है ये. सो फर्स्ट स्टेप इज सिंक्रोनाइजेशन ऑफ द टाइम. The second step is that the receiver is also beginning to transmit the same kind of code. मान लीजिए सैटेलाइट नंबर 9 था, तो सैटेलाइट नंबर 9 का कोड ट्रांसमिट हो रहा है. सैटेलाइट नंबर 9 का कोड ये जनरेट करता है अपने पास, नॉट ट्रांसमिटेड, बट इट इज when it is transmitted from here at the same very time, this code is also generated in the receiver. दोनों साथ साथ में सिंक्रोनाइज होकर के कोड हो रहा है. यहां से कोड ट्रांसमिट हो रहा है, यहाँ पे इसके अपने मेमोरी में जनरेट हो रहा है. सिंक्रोनाइजेशन होने के बाद ये होता है. पहले तो आगे पीछे होता है, बट एक बार सिंक्रोनाइज हो जाता है तो दे स्टार्ट ट्रांसमिटिंग. This starts transmitting the signal, CA code. This one generates the code. Now, when it is synchronized, is the receiver knowing कि अब ये चला है यहाँ से, अब ये चला है यहाँ से, अब ये चला है यहाँ से, because they are generating at the same time. Is the receiver now knows that at time T1, when it is generating, it is the same time when it has started from here?
Yes.
So time T1 is known to the receiver, because they are generating, this is transmitting, this is generating the code in the synchronized manner. The same phase of the code is received at this place. यहाँ से थोड़ा सा टाइम निकल जाता है, तो ये वाली कोड का फेज इसको फिर से मिलता है. जो यहाँ ट्रांसमिट हुई थी वही रिसीव करता है यहाँ पे. इस बीच में टाइम थोड़ा सा निकल गया आगे. जो ये रिसीव हुआ, ये वाले कोड का फेज जो रिसीव हुआ, दैट इज नाउ T2. So this one was T1 when it was generated, and the same code is again received here at T2. Can we find out the time between the two?
Yes, sir.
So time is T2 minus T1. So the range is equal to c into t. Speed of light, radio wave, 3 into 10 to the power 8 meter per second, multiplied by the time जब ये जनरेट हुआ था और जब ये पहुंचा, जनरेट हुआ और पहुंचा, t1 t2, time taken is this. Have we found out the range?
Sir, one thing. Sir,
Yes.
when it is transmitting, it is generating here, and then the time it travels to come and receive this, when the receiver receives the signal, that is T2 and T1. Is that correct?
Yes. Yes. Okay. Let us see this on the slide. स्लाइड पे थोड़ा सा समझ में आएगा, थोड़ा सा एनिमेशन आपके लिए बनाया हुआ है, तो दिस विल बी अंडरस्टूड ऑन द एनिमेशन. लेट अस, सिंस वी आर टॉकिंग अबाउट दिस, let us go to that particular timing and ranging. Allow me to share the screen. Timing and ranging आगे है क्या? Now that we are talking about timing and ranging, just read through this slide. और अभी तक समझ में आ रहा है? जो डिस्कशन हुई उसके बेसिस पे ये क्लियर होना चाहिए, अगर नहीं तो प्लीज बताइए मुझको, मैं फिर से एक्सप्लेन करूंगा. Next. Remember that the receiver is sorry, measuring the time between transmission and reception. How? वो अभी हमने बोर्ड पे थोड़ा बात किया था. This is how it is explained. The satellite is transmitting CA code. At the same very time, GPS receiver is generating the code within itself just for timekeeping, to find out कि ये कोड चली, अब कोड चली वहां से, अब कोड चली वहां से. तो टाइम T1 तो हो गया. T2 कैसे होगा? So, as we can see, the time is passing by. There is this code which is generated by the receiver. There is the same code which is being transmitted by the satellite. When you see, when the phase matches here, एक कोड और दूसरे कोड का फेज जब मैच करता है तो उस टाइम पे ये पूरा ग्रीन होता है. अभी मैच, ये देखो, when it is matching together, the phase of the two signals are matching. So अभी टाइम T1 हो चुका है, ये T2 आया, ये T2 आया. So जहां पे दोनों का सिग्नल मैच करता है, वहां पे टाइम T2 नोट होती है.
So that means, sir, at T1 both start, this receiver starts generating code, and when it
Yes.
matches the phase,
Yes.
that is the time T2, and that is the difference of time.
Yes. Basically,
Yes.
yes. Basically, yes.
So
Read
sir,
the
so that CA code will be for that satellite, particular satellite, which is already
एग्जैक्टली
known.
सबके लिए अलग अलग होता है ये प्रोसेस. सारे
Okay.
सैटेलाइट्स का अलग अलग प्रोसेस होगा.
Okay, sir.
सबके फ्लाइट टाइम जो होगा, सिग्नल का फ्लाइट टाइम वो अलग अलग होगा. कोई 45 डिग्रीज पे है, कोई ओवर हेड है, कोई 60 डिग्रीज पे है, डिक्लिनेशन आई मीन. तो सबका अलग अलग टाइम होगा, सबका सिग्नल आने में अलग टाइम लगेगा, तो सबका रेंज अलग अलग टाइम अलग निकलेगा, मल्टीप्लाइड बाय सी रेंज भी अलग निकलेगा. रीड द 2 लाइन्स एट द बॉटम हियर. Right. This is the difference of the time. The CA code being transmitted by the satellite is this. Remember that this signal was transmitted at this time. एक ही साथ ट्रांसमिट हुआ था और जनरेट हुआ था. जब ये वाली सिग्नल रिसीव होती है यहाँ पे, क्योंकि ये वाला सिग्नल आने में टाइम लगा, उधर से सैटेलाइट से उड़ता हुआ आ रहा है, तो when the same phase is received here, इतना टाइम निकल चुका है. थोड़ा टाइम पहले ये वाली पोजीशन जो थी वो यहाँ पे ट्रांसमिट हुई थी, पहले जनरेट हुई थी. जब ये रिसीवर का सिग्नल यहाँ मिलता है तब तक ये वाली चीज आगे निकल चुकी है. सो दिस इज टाइम T1, this one is the time T2. Can you see that both are having the same kind of codes and the phase are matching? ये दोनों पॉइंट एक ही है, लेकिन यहाँ पे दोबारा उसको मिला है, तो ये फेज डिफरेंस जो आया, दैट इज द डिफरेंस ऑफ टाइम.
Understood.
Good. So this is how the ranging and timing and ranging is done. Coming to the T code, both are comparable to some extent, but there is definitely difference. Again, we are talking about it is transmitted on L1 and L2 both. The T code is superimposed by phase modulation again on these two frequencies. Again, this is digital data or binary data in the form of 0 and 1 called a chip. This, since it is binary data, the speed of transmission has to be defined. This is faster speed. CA code was 1.023. This is 10 times faster. The chip length since this is 10 times faster, so the length of the chip will be reduced by 1/10. So how much was the length of the chip in CA code?
1 microsecond.
So this should be 0.1 microsecond. That 1 microsecond translated into how much of distance when multiplied by speed of light?
293.
293.
meters. So this will be 1/10 of that, 29.3 meters. तो यहां तक तो कंपैरिजन हो गया. Then the next point there which said that 1023 chips make one code. That was 1 millisecond. 1 मिलीसेकंड का एक कोड होता है. बट यहां पे the P code length is nowhere close to 1 millisecond. It is 267 days. Once the code starts, there is no end to it. साल भर वो चलता ही रहता है, कुछ नया ही आता रहता है. It is not repeating at all. It is not at all repeating. Something, once it starts at 000 hours on, let us say 1st of January midnight or 31st January midnight, when it starts, the code will continue for 267 days. Now you decide how many chips will be required or transmitted in this at the speed of 10.23 Mbps. एक सेकंड में इतना, तो इतने दिन में कितना डेटा ट्रांसमिट होगा? टेराबाइट्स की डेटा ट्रांसमिट होती है. So we are not talking about the length of this in terms of chips, number of chips, etc. 267 days. Now to transmit this kind of data, of course, lot of volume will be there, heavy memory required. So what is done? The data is transmitted for 1 to 7 days, then 7 to 14 days, 14 to 21 days. Weekly segment of data is uploaded to the satellite. The satellite is given only 1 week's data to transmit. फायदा क्या होता है? Satellite will not be overloaded. The ground stations will not be overloaded to transmit so much of data. But purpose वो नहीं है. Purpose is different. These are encrypted code. And encrypted code, P code is encrypted. अगर मुझे यूज करना है तो इसको डिक्रिप्ट करना होगा. So 7 days कोड के साथ एक पासवर्ड भी आती है जो यूजर्स को दे देते हैं. The password is given to the users. Who are the users?
Defense personnel, defense officer.
So they can use this P code only for 1 week with this password. After a week, this is new set of data transmitted and new password given to the users. That means अगर पासवर्ड किसी को मिल भी गया गलती से एक बार, तो 7 दिन के बाद वो खत्म हो जाएगा. So the code length being so long, only 7 days segment of the code is uploaded to the satellites. Along with the code, there is a passkey which is circulated amongst the users to make use of the P code. But if I switch on my receiver, how do I find out कि अभी कौन सा कोड चल रहा है? ये हो सकता है कि अभी राइट नाउ 110th डे का कोड चल रहा होगा, या 220 डेज का कोड चल रहा होगा, या 176 डेज का कोड चल रहा होगा. सो रिसीवर शुड अगेन सिंक्रोनाइज, जैसा यहाँ पे हुआ था पिछले में, सिंक्रोनाइजेशन होनी चाहिए. तो कैसे पता चलेगा कि अभी कौन सा कोड चल रहा है? कैसे पता चलेगा आपको कि मेरी एज कितनी है?
when we enter the
I guess. But if I tell you I was born in 1970, can you tell me my age?
yes sir.
So you can calculate and 21, okay, 50 years, 51 years, whatever. Similarly, for the P code, every 6 seconds, start of P code is transmitted every 6 seconds. जो सीए कोड में रिसीव कर रहा हूं हर 6 सेकंड में पता चलता है कि द कोड हैड स्टार्टेड बैक देन. हर 6 सेकंड में रिपीट होता है कि द स्टार्ट टाइम ऑफ द कोड वाज सो एंड सो. दैट मींस इफ आई एम हियर आई विल गेट इमीडिएट इंफॉर्मेशन दैट द कोड स्टार्टेड हियर सो दैट आई कैन कैलकुलेट कि अभी यहां का कोड चल रहा है. So this allows quicker synchronization for the receiver to find out the position. One thing to note here is that the P code is common to all satellites. जैसे CA code was unique, all the 24 satellites having different codes. The P code is common. सभी एक ही कोड ट्रांसमिट करते हैं. लेकिन तो हम काम कैसे करते हैं? तो पहले CA कोड पे आता है, फिर CA कोड से P कोड पे ट्रांसफर होता है उसी सैटेलाइट के लिए. That means a correlation is made with the CA code and the P code, ताकि मैं किस सैटेलाइट का P कोड यूज कर रहा हूं वो कनेक्टेड होता है CA कोड से. So this is the CA code, P code, and how the ranging is done.
Understood.
Any questions? Overload हो गया?
No sir, no question.
अमितोष ओवरलोड हो गया?
नहीं सर, ठीक है.
ठीक है, चलो, good to know that. Good to know. ठीक है, so we sign off. Any questions?
No sir.
चलिए, ठीक है.
No,
Then
sir.
signing
Thank you
off.
sir. Thank
We
you.
meet again in the last class. We'll continue with this. We'll talk about navigation message and some more. We are in the middle of the topic. तो अब खत्म होने में होएगा, 1-2 और क्लास में खत्म हो जाएगा. Signing off. Bye bye.
Bye sir. Thank you.
Bye bye.